Okay, let's talk now about the paired t-test. Why would you choose a paired t-test rather than an independent t-test? Well, ask yourself this question. Do you have two pieces of data for each person? Typically, a way to consider that paired t-test is if for, say, Susie, you have a pre-test, post-test. That's easy. Or if you have in the exercise data set a heartbeat before running and after running for the same person though, right? In the HSB data set, if you have for each child in that data set a social science test, a math test, a science test, an English test, then you can do a paired t-test and see how did Susie do on social science versus math. And then how did a whole group of kids do when this same group took both a social science test and a math test? Or each of these people measured their before run and their after run pulse. Or a kindergartner took a pre-test before the year began and then after the year began. There needs to be a very strong reason to tie the two tests, the two measurements together, and it's usually through the participant. So hopefully that helps. It's so easy to get these confused. Please write if you have questions, especially with the homework. But let's, for the example today, look at what I've written here. I've done a little bit of work here to get us ready to go. See if I can move this over a little bit. Oh, I'm not great with this. But here we go. My research question is, did my homeschool children improve their reading score during the year? And my null hypothesis is there's no difference in the pre-test and the post-test score. But my research hypothesis is yes, that reading score should have improved, right? We would expect children in school to be able to improve their scores by the end of the year. Well, that makes this a one-tailed test because I'm only going to look for improvement. I'm not really going to worry about if they slid behind. That's a whole other issue that I'm not really worried about. If it was a two-tailed test, I'd say, well, I'm equally interested in whether they improved or whether they decreased their scores. But in this case, I'm only interested in improvement. If they stayed the same or increased, that's just not going to be okay. They should have improved, and that's what I'm looking for. So, as before, you can go into data and use the data analysis option. And here's the paired two-sample t-test right here. You see it pops up in this box. When you click OK, we can put I tend to like to put the post-test in my first box. And then in my second box, I like to put the pre-test. Notice that I'm highlighting the title on top of the column here, and so I'm clicking this box that says labels because I have a label included, and I'm hoping this will solve my problem with degrees of freedom. Okay, when I click OK, I get my results, and here I've made them huge here so that you can read them. And I solved my problem with degrees of freedom. Now here's what's strange about a paired t-test. In this case, my sample truly is only 20 because each child has two measurements, whereas before my sample was 40 because I had two different groups. Now my sample is 20, and I really only have to calculate one mean. The mean that I calculate is the mean of the difference between each child's pre-test and post-test. Sadly, that doesn't show up in here, and so I understand that this might be confusing. Please write to me if you have questions as you think through this. And it's okay for you to let that part of it go. The degrees of freedom is something that we don't teach until a second level doctoral course, so you can trust me on this one. If I wanted to write this up, I would write that P, or actually T, let me pull up my sheet here. So I'd say there was no significant difference. I cannot reject the null. That means basically I need to do more work. Something is weird here. I was sure they should be doing better and they're not. Maybe it's time for a little qualitative research, right? Like maybe the parents ran out of time and they didn't have a chance to teach their kids the way they wanted to. So I'm going to put a T in here with my, now Excel or Word wants to automatically capitalize it, and it's really supposed to be a small t, and it is supposed to be italicized. Here's where I put my degrees of freedom. And let's go back and see what was our t on the spreadsheet. It was 1.18. We'll put that in here. And then p equaled I think it was 0.1258. Okay, so I'll stick that in here. And let's just test ourselves and make sure that we get the same results when we use GraphPad. So here I am on that website. I've got t-test to compare two means. I'm going to continue because so far it is a t-test, but now I'm going to click this box. Now I'm doing a paired t-test. If you want more information, you can click on Help Me Decide. Okay, I'm going to paste my rows. If you click enter up to 50 rows, you have to enter by hand. No fun. And I'm going to go back here to my data on sheet 1. I'm going to put the post test in first because I'm expecting the post test to be bigger. If that makes sense, I want to do the bigger minus the smaller because when you do this kind of a test, it's group 1 minus group 2. So there's group 1, which is going to be my post test. Group 2 here, I'll copy, is going to be my pre-test. Okay, and let's calculate. Okay, so here are our results. It looks like we have, oh, it gave me the unpaired t-test. I must have done something wrong. Did I click? Oh, it went back. Let me click paired again. I was looking at those degrees of freedom, and once again, those are really a great indicator of whether you've done the right test. Okay, here we go. T is 1.18. Degrees of freedom are 19, and my p-value is 0.2517. Well, wait a minute. I wrote on my sheet of paper that my p-value was 0.1258, but notice this is one-tailed. And when I come here to the website, I don't have the option of asking for a one-tailed p-value. If you ask for a one-tailed p-value, let me copy this, and you end up with a two-tailed p-value, well, this p-value right here, we can divide it by 2 because we're dividing it by the two tails to get the one tail, and it equals 0.1258. If you want to pull out your calculator and check, you can. If you're like me, you'll want to pull out your calculator and make sure it's true, but it is. And that should hopefully give you a quick, down and dirty couple of ways to come up with those p-values, to come up with a conclusion. Then I would like you to interpret this a little bit. What does that mean? That means that the homeschooler spent a whole year and weren't able to improve their reading. I might have expected a little bit of improvement just because they're growing up. And it didn't happen. There was no significant difference. So give me some of your opinions on that. I'd love to hear what you think my next step should be, what might have gone wrong, what might be happening. Have fun with it. I'm really looking forward to reading your assignments. Thank you.